Hello everyone. So apparently NASA is getting into the nuclear reactor business, so I suppose it was a good time for me to try to figure out all these things, including the shadow shields and the radiators and all of that business. And I have been thinking about how to optimize the shadow shield. The shadow shield is a very, very heavy component because it's blocking all the radiation from our reactor or potential nuclear engine, fission, fusion, whatever. And it is generally made out of, say, lead or tungsten, plus borated polymers, plus water to block different kinds of radiation. And on this vessel, for instance, it's on the order of about 40 tons. And, well, it's going to block the radiation in a particular cone. The actual engine or reactor would be on this side, and then everything has to fit inside the cone that is blocked by the shadow shield. And I've got that volume like this, and so we can see with the wireframe that the radiators and the tank all fit inside that cone. But, well, could we shape the shadow shield in a way that better reflects the shape of our vehicle? I mean, all the shadow shields I've seen have been sort of straight cylinders. I'm sure it's very easy to manufacture those. But what I'm considering is maybe a more custom shape than a cylinder, because when we take a look at this, yeah, the tank fits exactly right. But after that, our habitat doesn't take up all the space. You could make a habitat take up all the space if it was, spinning or something like that. But then if you're having something rotating on one side, I don't know. The physics of angular momentum always worry me. But anyway, you could do that, and then that'll take up more space. But right now, we're just fitting the radiators like this. And so what we would like is a shadow shield with a cross-section more like this, right? Something that accommodates the radiators more and maybe allows them to poke out more instead of just this cone, because a lot of the cone's volume is not getting used, if you can see that. So I thought of instead this. So now we've got a tighter sort of thing. Now our tank is poking out, so we're going to need a new tank. But if we take a look at it, the shadow shield looks like this. Now, what are the downsides to shaping it like this? Well, your engine had better be shaped more like this too. One of the things about the circular or, cylindrical shadow shield is that, well, if you have an engine that's also that shape, then it fits it perfectly. So if you're going to use a shadow shield that looks like this, you're going to have to sort of deploy your engine, arrange your engine so that it meets this shape efficiently. And, maybe you have reactor modules that are off to the side as well, instead of clustering them in a single cylinder, for instance. It depends on how the shape of the engine is. And then we have to change the tank. Obviously, this tank is poking out, so we alter it to be a more conformal tank. So it's more like that. And if we take a look at it without the envelope, it's like this. And now, instead of having the arrow radiators, this whole business can take on a very different shape. It can take advantage of the extra volume, and so we can have the radiators go out all the way out to here. And so that's a better arrangement for us. And we could even make the tank wider. We can see that there is some space there. Or we could put radiators along that, since that part of the envelope is fairly thin. All right, it sort of tapers like that. So we could put radiators all along the way there. And with a greater radiator capacity, that means that we can accommodate more powerful engines, right? The engine thrust can increase, the engine ISP can increase, all thanks to the increased power allowed for by the radiators dissipating the heat. And we saw on the, let's take a look at the NASA concept for their nuclear reactor to Mars deal. Here we are. So this was very peculiar because they've got their radiators arrayed as an X. But I suppose I should explain, why do we have our radiators flat like that? Well, the reason is because if you have them like an X like this, if they're radiating on both sides, then the thing that they radiate are little photons. They're carrying away heat, and they're photons in the infrared spectrum usually. And they would be sending their photons at each other, which would limit how much the radiators could release the heat. You don't want the radiators facing each other because then they're releasing the heat at each other. Now, it's possible that these radiators are unidirectional. In other words, they're only releasing the heat in one direction. However, the artist's conception does not seem to indicate that. You can have them in an X if they're at 90-degree angles to each other. That does reduce their efficiency, but not that much. Because they're at 90 degrees, but these aren't at 90 degrees. They're sort of like in an X-wing thing, and that wouldn't be good. You would want them, if you're gonna have 4 of them, you might as well have them as an X. So that does get back to our design of the shadow shield thing, where we can design the shadow shield as an X then, if we want to, and accommodate the exact radiator configuration, because all we have to do is block the radiation within that area. Now, they've got a circular shadow shield on this one, and that's fine because, you know, they've got stuff sticking out and everything. It's not as tight as what I've got. They do have a lot more room to work with on this end. Oops. Oh, no. I need my cursor. They do have a lot more room to work with on this end if they wanted it, but they apparently don't want it. They've got these stubby little solar panels. They could, you know, boost the power of the ion thrusters, maybe have 4 of them and have larger solar panels, but anyway, they're not going for that. Would be maybe a good idea, but anyway, the point is that if they've got an X, then you probably just would go with the circular sort of shadow shield, because trying to make the shadow shield as an X might be a little bit too finicky. But it is interesting that this artist depiction has chosen an X. There is a balance between, you know, when should you use an X and when should you just have them all flat so that you don't get a reduction in efficiency. And when you would use an X is if the shadow shield is really, really heavy compared to the radiators. And probably it is. If the total amount of radiators you need, it ends up being very, very heavy compared to the shadow shield, then you don't want them having a reduction in efficiency at all. So we have on our model 40 tons of shadow shield. If we also had 40 tons or more of radiator, well, then in that case, we would want to make sure that the radiators are flat and there's no reduction in the efficiency of them, so that we minimize their mass. Because if you have them facing each other, you're gonna need more mass, radiator mass, in order to get the same heat rejection. If, on the other hand, your shadow shield is super heavy compared to the radiators, then you can have 4 of them. You know, you can have them in an X configuration or a cross, and in that case, you accept the fact that they're being less efficient because you can fit them within a smaller shadow shield, right? You can make the shadow shield tighter. You know, you can shrink it down, and they'll still fit, and then it's all right because you've reduced the thing that is heaviest. So then you can have 4 of them, and probably you'd want a circular shadow shield for that. But this is all amusing on how we might shape this other than the canonical cylindrical way, because I'm still working on how to make my spaceships look different. And so this is part of that. So we have another option. The other option is to not have the shadow shield be a circle or a cylinder, and then we could make everything else look quite different. And I haven't made everything else look quite different yet. I've sort of reshaped the tank, but we can, with this shadow shield, make this all a little bit more tailored to that new shape. So that is the idea, that's the concept, and I'll continue working on that and other radiator ideas. And who knows, maybe at least NASA's concept artists will figure something out. So anyway, continuing to work on the future here. With that, thank you for watching. Hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below. And I'll see you next time.